Hello, dear students. This is Dr. Sourav's class. We are now solving our UPSC Mathematics Optional Paper, Paper 2 from 2024. Hope you are doing well and studying very hard for your upcoming examinations. So, all the best and let us see the question what asked from. So, they have to we have to consider the polynomial ring zx over the ring z of integers. Let s be an ideal of zx generated by x. Then what will happen? Then they have okay, then we have to show that s is prime, but it's not an maximal ideal of zx. Okay, so we are tasked with analyzing the ideal is, yeah, that's all. Okay, now, yeah, x is equals to this, as it's generated by our x in the ring zx, which is the set of all polynomials with integer coefficients. And especially we must know that s is a prime ideal and it's not a maximal ideal. So now the definition of x is, which is equals to this, x into fx, where our fx is belongs to. So this consists all the polynomials in zx that have x as a factor. So now we show that S is a prime ideal. How can we do that? Okay. So let me change my color first. Then an ideal, I in a ring R is prime if for all our fx and gx belongs to R. What happens then? Then our fx gx belongs to I. Then, sorry, mistaken here. Oh, okay. fx gx belongs to R such that our fx gx belongs to I. Then what happens? Then either our fx is belonging to I, otherwise our gx is belongs to I. Okay, how can we prove that? Let me again change my color. Okay. So suppose our fx and gx belongs to z of zx. Okay. Then and our fx gx belongs to x. Then what will happen? Then it as the element of s, anything will look like x fx. So our fx gx will have to look like this, where hx will belongs to our zx. So this implies that x divides fx gx. And now, since we know that our x is irreducible in zx, then it follows that x will divide either fx or x will divide gx. That means our fx will belongs to s or our gx will belongs to s. Why? Because we know that the elements of s has x as a factor. Then when the polynomials are in s, they have x as a factor. Then x may be x always be a factor of this. So our fx or gx has a factor x here. So our fx or gx will belongs to s, and that matches the condition which is given here for our prime ideal, and this is this. Yeah. So our let okay. So our S is prime. This is proved here. Hope you guys understood. Again, I am saying that our x divides fx or x divides gx means that x is a factor of fx or gx. So then if x be a factor of it, then our fx will belong in S, or our gx will belong in S. Then the condition is satisfied for the prime ideal. Then our S is prime. It's proved. Now we have to go to the second part of proof. Yeah. So now we have to show that S is not a maximal ideal. Yeah. So an ideal I in a ring R is maximal if there are no other proper ideals J of R such that our I. Oh, so now the ideal given as this is not maximal, is not maximal because there exists a larger proper ideal, we proper ideal of zx containing s, which is our this. Can you see my screen? Yeah. Okay. Which consists all polynomials of the form of which kind? This is a, yeah. May I, yeah, of which kind? They are looking like this. 3x2, where our ax and bx are belongs to that. We can easily see that our this thing will lie inside. Okay, so we can easily see that our s is maximal here. So our s is prime, that is been proven, and this is not maximal, this also proven. So the final conclusion is the ideal s equals bracket x is a prime ideal in zx because the product of two polynomials being a in S implies that at least one of the polynomials is in S. And for the conclusion 2, we have appeared that the ideal S is not a maximal ideal in zx because there exist proper ideals strictly containing s. That's point to be noted, which is ideal strictly containing s, that is our this. Okay, hope you understood. Thank you guys.